objective of this project is to perform a video in which we will describe some concepts seen in class. For example, the probability function, the density function, and the cumulative distribution function, and finally, the probability calculations in general.
Probability function. A function of discrete random variable that gives the probability that the outcome associated with the variable will occur. Probability is a probable event circumstance that might happen, or is a strong likelihood or change of some.
What if we flip the fairy coin 4 times? What are the possible outcomes and what is the probability of each? This is a probability distribution for the number of heads in 4 flips of a coin. Given that the probability of heads is equal to 0.50, the probability of not flipping heads at all is 0.0625. In 0.0625 of all trials, we can accept that there will be no. This might be written as probability of 0 is equal to 0.0625. Similarly, the probability of flipping heads once in 4 trials is 0.25. In 0.25 of all trials, we can expect that heads will be flipped exactly once. This might be written as probability of 1 is equal to 0.1. The density function is a function that describes the relative likelihood for this random variable to take on a given value. What is the probability that a randomly selected hamburger weighs between 0.20 and 0.30 pounds? That is, if we let x denote the weight of a randomly selected quarter-pound hamburger in pounds, what is the probability between x 20 and 30? If you weigh the 100 hamburgers and create a density histogram of resulting weights, perhaps the histogram might look something like this. In this case, the histogram illustrates the most of the sample hamburgers in the weight close to 0.25 pounds, but some are a bit more and some a bit less. Now what if we decrease the length of the class interval and the density histogram? Then the density histogram could look something like this. Now what if we push this further and decrease the intervals even more? You can imagine that the intervals could eventually get so small that we could represent the probability distribution of x not as a density histogram, but rather as a curve by connecting the dots at the tops of the tiny rectangle. The area of the entry histograms equals 1. That suggests then that finding the probability that a continuous random variable x formed in some intervals of value involves finding the area under the curve fx sandwiched by the endpoints of the interval. In the case of this example, the probability that randomly selected hamburger weighs between 0.20 and 0.30 pounds is then this area. The cumulative distribution function of a random variable x is a function. The cumulative distribution function gives the probability that the variable takes a value less than or equal to x and is defined for all real x. First, if we look at the graph, we see that the cumulative distribution function fx must be defined over 4 intervals. The definition of fx4 is easy, since no probability accumulates over that interval fx equals 0 for. Similarly, the definition of fx4 is easy, since all of the probability has been accumulated for fx beyond 1 fx4. For the other 2 intervals, we realize the next 2 integrals.
Created using Powtoon.